Hello, my name is Sangeet Cheda, and as a prototype for design project for instrumentation and measurement module, I have designed a rain sensor using Arduino Uno. So to begin with, firstly, the key components of the project include an Arduino Uno board, a sensor, and a breadboard. It also includes an LED and a buzzer. So to begin, the Arduino Uno board, it usually consists of a microcontroller, some analog and digital ports, and a terminal which can be used to connect to a computer to interact with IDE. IDE stands for Integrated Development Environment, and it is usually a platform where a code is developed for the Arduino so that it can perform some specific function. Moving on to the second component, this is the rain sensor. It usually consists of two components. The first one is the rain board and then a control board. A rain board consists of two copper tracks which are designed in such a way that they provide high resistance when it is dry. As it can be seen here, the two copper tracks, they are not connected and they have some space between and provides resistance. And the control board is actually an LM393 operation amplifier, which usually compares the output value with the threshold value, and it consists of a potentiometer which can be used to change or alter or calibrate the sensitivity according to the kind of threshold value that we require, and a 4 output port which can be connected to the microcontroller, Arduino Uno, so that it can interact with Arduino. And the connections are as shown below. The analog output of a sensor is connected to the Arduino output, the analog output of the Arduino pin, and the sensors, the VCC, is connected to the 5-volt pin of Arduino, and then the sensor ground is connected to the ground of the Arduino. The positive of LED is connected to the Arduino 11 port over here. The negative pin is connected to the ground, and for the buzzer, the positive one is connected to the Arduino 10 port, and then the negative to the ground. The connections are as shown below. The Arduino is connected to the PC, where the IDE platform is installed, and this program provides a platform to develop a code, as I mentioned in the beginning of the video. So as the code is already developed here, it is uploaded inside the Arduino, and then after that the code, you can see the output from the tool tab, and we can open the serial monitor to view the output. It can be seen the output value as of now is 700, and the sensor is still dry as of now because we haven't applied any water or any rain. So in this case, the weather is very sunny and there is no rain at all. Now it can be considered that a rain has started to fall, and it hasn't reached the sensor right now. So as you can observe from the serial monitor, that the values are still 698.9, which is quite high. So now if I apply a water over here, can you see that you can now consider that a rain is falling. So if you put a water over here, it can be seen that the value has drastically decreased from 690 to 232 to 41 to 80, and is still decreasing. So we can now increase the quantity of water and to indicate heavy rainfall. As it can be observed, the value are slowing down, it's going down. So let's assume that the rain are still falling. So the quantity of water is increasing. So if we apply water, now it be seen that the buzzer and the LED is making a sound, which indicates that there is a heavy rain. As it can be seen over here, it indicates a heavy rain, and that's how the circuit will sense heavy rain. Okay, let me demonstrate one more time. So it can be seen that the sensor is still dry, so now there's a heavy rain. So when the rain falls, it covers all the surfaces of the sensor, which decreases the resistance because the water conducts, the resistance decreases, and the circuit becomes complete. Still, the alarm on the buzzer hasn't made sound because there isn't a heavy rain. So I'm still adding some water over here to indicate heavy rainfall. Now you can see the rain is very heavy, and the alarm and the buzzer is making a sound. Now consider that the rain has stopped, and then the weather is becoming fine again. So the rain will dry again, and then the sensor will get dried, and it can be seen that when the rain has stopped, the alarm or the LED has stopped glowing. So that's how the water sensing sensor work, and this kind of sensor can be employed in the modern electronic windows and shutter, as well as a retractable roof, whereby when it senses the rain, it can automatically close and open when the weather is dry. Thank you.